So I am making a YouTube video to show you how to solve for the Chapter 3 preparation quiz, and you get kind of, this week to work on this quiz, and when you come into class, the next class, the real quiz will be just like this quiz in terms of formatting. The only thing that'll be different is the data set. So let's go ahead and get started. You can just open up the file that you can, and it prompts you for the student password to take the quiz. So and the idea here is to take the entire quiz on your own before you looked at the graded password and see what the right answer is. Here you can see, since it's a practice quiz, I give the graded password to you. It is practice, so you could just click in this password thing and type in the practice as the password, all lowercase, anytime you wanted, and see the solutions. But it's a better idea to really figure out what you don't know first. So 1. Summarize the quantitative data. The count. Count is just how many data points we have. Each data point is represented by xi. So I can see that the count is 19, or if I want to use a formula, I can hit equals count and select all of the data. 19. Sum. Just use a nice sum formula here. Don't get confused because this is a percent. It's a percentage. We're summing all these percentages up, so it can be more than 100%. Now, sample mean. In order to find the sample mean, if you remember, we take the sum and we divide it by the count. And sample mean also represents, we represent that with x bar, which is this guy right here, sample mean. And the mode, which is just most common. So we don't want to use the mode function here because it's easy to eyeball it, and I ask you not to use the mode function. And we can see that the most common value is 100%. So we can just type in a 1. Oh, but we see the percentage thing's already in there, so type in 100. Great. Now going on to step 2, calculating the 37th percentile. And here you see I throw some formulas in here into the workbook, but if you look at my formula sheet, which will now be on the board during quizzes, it can cue you in a little bit more. Anyway, starting out, P, if you're not sure what P divided by 100 is, you can look on the formula sheet, and right there, P is the pth percentile. So in this case, P is 37. So P divided by 100 is equal to 37 divided by 100. N plus 1, remember N represents the count, so we have the count right here. N plus 1 is going to equal the count plus 1, 20. The mode. Now, we already calculated mode one time. We know it's 100%. Now I star is represented by the index. Here's the formula for the index, and it says I star equals m plus 1 multiplied by the p divided by 100. There's your I star. Now I star represents the position in which is used to come up with the given percentile. But there's no 7.4 position. So we have to use I and I plus 1. I is simply I star rounded down. So we're going to use the round down function. You could just type in 7 here, that'd be fine. I'm going to use the round down function. Too few arguments. So the first argument is the number that we're rounding down, 7.2. The second argument is the number of digits that we round to, which is 0 in this case, 7. Another nice thing about the round down function is that sometimes you can be displaying, your formatting won't show any digits or it won't show whatever you want to round down to, but if you extended it out it would. Like in this case, well, you can extend it out and you can see it's just 7.4 all the way, but sometimes if the formatting, this could be 7.1, but if the formatting was set like this, you wouldn't see that, and having the round down function would prevent, this 7.4 from looking like a 7. You're rounding it down, so it's going to be a 7 instead of 7 with a hidden decimal point. So, sorry to beat a dead horse. Anyways, I plus 1 is just going to equal I plus 1, or 7.4 rounded up. F of I, now this represents the value, the observation, that is located in the ith position. I is 7. So what is the value that's located in the 7th position? Here I can go and see it is the 90%. What I'm going to do is I'm going to use a Vlookup function because Vlookups are important. Vlookup, and then the value I want to look up is 7, and then the table array I want to use is this entire table array, and I want to put dollar signs around everything right here. And then after the dollar signs are in, we want to pull from the second column and false. So you may remember that what a Vlookup does is it takes a table array right here, so that's the second argument, and it says we're going to look for, in the leftmost column, we're going to look for whatever you put right here, which in this place is a 7, or you could type in 7 instead of this L41, but we'll leave L41 in there. So it looks for the 7, and then it says, oh, I'm going to go, once I find it, I'm going to go to the second column. So it finds the 7 right here, and it goes to the second column. It's a 90%. The false is optional. It's optional because it has the brackets on it, and that says that it looks up in exactly 7. Whereas if this was true, we would still get the same result into this case, but if our I wasn't 7, let's say it was 7.5, or a better one would be, let's say I was 8.5. In this case, it doesn't find any 8.5, it just finds a number close to 8.5, which I'm guessing would be 8, and then it's pulling the second column. But if we had, instead of true, we had false in there, now we get an error. And it's because we realize we're looking for something that's not there in the first place. There's no 8.5. So that's why I like preferring false, because it can cue us in case that this original value is somehow an error in the first place. So we're going to change it back to the right answer. Again, too few arguments. Number of digits equals 0. And let's change the formatting back to it's pretty 7. Great. So we can just copy this formula because I was very careful about the dollar signs and the L41 and here down to this next bracket. and let's just do a quick eye check to make sure it's right. It's looking for the value associated with the 8th position. Here's the 8th position, and there is your 90%. Now weight sub I plus 1. Here's another example where the formula sheet can be helpful. I can look in the formula sheet kind of under this percentile section, see that the weight of I plus 1 equals I star minus I. So I star minus I 0.4. And let's look at what's the formula for W sub the weight of I. Looks like it's I plus 1 minus I star. So equals I plus 1 right there minus I star. And it looks like that's not coming into a format that I really care for. There we go. Show off the decimal. Now the 37th percentile, we take, it is equal to the weight sub I multiplied by the value of the ith place plus the weight associated to the I plus 1 place multiplied by the value associated with the I plus 1 place, 90%. And right away, you could have realized that this, if f of I and f of I plus 1 are both the same value, then when you look for a value in between them, it's going to be the same. Which effectively, that's what you're doing with the weight. You're looking for a value in between these two values. So, 37th percentile, 90%. So moving on to finding the sample variance. Right here we have the sample variance formula, and this is, to help you find it easier. The xi minus x bar and the xi minus x bar squared. You can look at the formula sheet right here if you somewhat forget, and you can realize, oh, x bar, if you forgot, that represents the sample mean. It's just, a literal representation of this notation. So that's x bar for you. And because sample mean is just the sum of all the points divided by m. So we already have what x bar is, and because x bar is the sample mean right there, so here we want xi minus x bar. Xi is 70% or 0.7, and we're going to subtract x bar, which is the mean. And in this case, I'm going to put some dollar signs around the x bar. That way I can just copy this formula down. Copy, select all that, and paste. So I'm getting a sum right now of 0, which is correct. If you're not getting a sum of 0, then double check right here. And anyways, now we're looking for xi minus x bar squared. So we're just going to take this cell right here and square it. And I'm going to copy that, bring it all the way down, and paste. Looks like everything came up right. And now we have our sum of xi's, which xi represents each observation. So we're going to sum all the observations. And our sample size, we can use the count function, obviously just on the xi. And our sample mean is, we we have that over here. It's 0.92, but we will do it the old-fashioned by hand way. Sum of xi divided by sample size, 0.92. And then sum of standard deviations, SSD. We can look on our formula sheet. Nope, here it is, SSD right there. It is the sum of those values, xi minus x bar squared, and we sum all of them together. So sum, these values represent xi minus x bar squared. That is our SSD. And our sample variance, let's look at the formula. Sample variance is, the sum of all these things right here divided by n minus 1. And maybe that formula is kind of confusing, so we'll look on our equation sheet. It looks like sample variance is the SSD divided by n minus 1 as well. That's right, because SSD represents this numerator. So it's going to equal to SSD divided by, parentheses are important under the dividing sign, n minus 1. There's our sample variance. And it can be in a decimal form or it can be in percent form. Does not matter. Standard deviation right here, that's represented by an S. It's just the square root of the sample variance. So I can do square root of the sample variance, or I can do, that's the same thing as taking the square variance to the 1/2 power. Alright, looks good to me. So here we want to solve mathematically without using the variance, standard deviation, covariance, and correlation functions, but we can use the average function. So x bar, if you remember, just represents the sample mean for the x values. I said we can use the average function, so let's just do that. Average all the x values, 88%. And we're going to do the same thing for the y. Average .053. Great. Now let's fill in the x minus x bar column. Equals x minus x bar in dollar signs to lock it in place. And now I can just copy all of this down. X minus x bar squared. So there's our x minus x bar. Let's just square it. And I'm going to drag that down. Y minus y bar. So here's our y observation. Subtract y bar from there. Drag that down. There we go. And same thing here. Y minus y bar squared. So we can just take this and square it. Oh, looks like, we're getting all these pound signs. Oh, we can see, the 1.108, blah, 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 blah. It looks good. Looks like we just might have to fix, some decimal points. So let's do 3 for the heck of it. Copy and paste down. Let's just double check. Oh, yep, looks like it's picking up that cell and squaring it, which is what I want. Now, so in the formula it's looking for your xi observation minus the xi, the sample mean of all the x's, which is x bar, and then multiplied by y minus y bar. So let's just do that. X minus x bar multiply by y minus y bar. Copy and paste all the way down. Great. So our sample size is 19. Now notice how sample size I just used the count of x, not a count of x and y, not everything in this table, because this x-y combination represents one observation, and sample size is the number of observations that you have. So we can just do the x's, or we can just do the y's, or the number of students, 19. Sample mean. So you can find the sample mean that's actually equal to x bar. Let's use the average. Select sorry about that. Select everything in the xi data set, and sample mean of the y equals average. Are these the same as x bar and y bar? Yep, that looks good. Now sample covariance. It equals the sum of xi minus x bar multiplied by quantity y, so I minus y bar. So sum, there we go. That's the numerator right there. Now we need to divide by the denominator, which is n minus 1. We have, oh, no we don't. So parentheses n minus 1. Sample correlation. Now, maybe this isn't completely obvious looking at the formula, so we can look here, and I can see, oh, sample correlation. This sign right here represents is defined as. It can often signify notation. So here we have sample correlation. The notation is R x y. Then we have S of xy over S of x and S of y. And I wrote down what each of these things are. So it is equal to the sample covariance. That's this guy. Divided by the standard deviation of x. That's this guy. And the standard deviation of y. That's this guy. So now we have a little bit better understanding what that is. Our variance of x. What is variance again? Let's go up and look at this formula. The sum of xi minus x bar squared over n minus 1. Sum all these x minus x bars squared divided by parentheses n minus 1. Or we could just type 18 in, that'd be fine too. Standard deviation of x equals to the 1/2. Sorry, you can see it's really late. I'm almost falling asleep while I'm doing this video. But I really want you guys to be able to get this stuff. So variance of y, same thing. Sum of y minus y bar squared divided by n minus 1. So parentheses n minus 1. Let's double check, make sure I did this right. Yeah. because I was kind of falling asleep. Ugh, divide that by 2. That's ridiculous. Standard deviation equals the variance to the 1/2 power. I should know that in my sleep. Which is the same thing as, you know, taking the square root of the variance. So we can take this formula and apply it right here, and it is taking this the variance of y and square rooting it, and now we can figure out what our sample correlation is. It is the sample covariance right here divided by, let's put parentheses around this, your standard deviation of x multiplied by your standard deviation of y. And you want to be careful, use standard deviation here and not the variance. So that's it. Let us see how we did. So we can go to this password section right here and put in the graded password, which is practice. And now what happens is the graded tab pops up, and here's your answers in the graded tab, and here's the correct answers, and we can scan down and see, looks like we got them all right, and your answers are right. This is a lower bound and upper bound. If your answer is between the lower bound and the upper bound, you have the correct answer. So now let's go back and to the student answer sheet, and let's suppose we had a wrong answer. Let's say down here what happened was for variance of x, or let's just do right here, sample size n, let's say we got that wrong for some reason, we put 15 instead. Now if you went to the graded tab, you notice that answers that boxes that you put in that are different are going to be in the yellow. So we can scroll down here. Well, first we'll check to see, oh, it looks like we got 2 answers wrong. What happened? Let's see what cells are different. And I can scroll down and say, you know, it appears that these cells are different from what I had. Notice the cell on the graded tab is the correct answer. This has the correct formula in it. So when you're trying to figure out why is mine wrong, look at the graded tab, because this has the correct answer in it. But I can see that, you know, these equations all, the ones in yellow, I must have answered differently somehow. So we can go back to the student answer sheet, go back down to the same spot, and I'm like, oh, yeah, look right there. It's 15, and let's check. Oh, it's 19. Why is it 19? Oh yeah, I just made a silly mistake. So I'm going to make that equal to 19. Now we can check the graded again. And oh, looks like things were corrected. And now it appears we have all the right answers. I'm ready for the quiz. Thank you.